Welcome to the session. Greeting of the day. In today's class, we are going to talk about non-destructive testing processes. In previous session, we have talked about the destructive testing process, and in continuous with it, we have to do the non-destructive testings also. Those in the destructive testings, we have disturbed the specimen and break the specimen. But in the non-destructive testing process, we are not going to break. And without breaking, without affecting the specimen, we are going to test the defects. So non-destructive testing contains the weld inspector should have a working knowledge of entity methods and their applications, advantages and disadvantages, because if the radiography is there, this is the most harmful one. Therefore, we should know various disadvantages of this process also. 4 basic entities are there, 4 to 5 welding processes are there, such as the visual inspections, radiographic inspections, ultrasonic inspections, and magnetic particle and dye penetrant inspection test. So we come to the next of magnetic particle testing. So surface and slight subsurface also detected here. So magnetic particle testing mainly useful for surface defects and secondarily slightly useful for subsurface defects. Relies on magnetization of component to be tested. This principle we are using is a magnetizing method. We are going to spray the iron particles over there, and iron particles are going to fill the cracked items. And when magnetic particles is kept over, the remaining particles are comes out. The iron particles which are in the cracks, it will show the results. So likewise we are going to, you see here, in this image, I am keeping the north pole south pole magnetic particles here. And I want to, this is circulating, this is going to north pole south pole, attracting, it is circulating the field. When there is a defect in the specimen, and when I am connecting the specimen of magnetic gun over there, due to this field effect, it want to travel here to here, it want to travel over here to here. But what happens, due to this cracking scenarios, this field will jump and goes there. So this jump we are using, how we are using, see, I am pouring, I am keeping on magnetic particles, iron particles, I am keeping these iron particles here, in between this one. When I am keeping this iron particle here, these iron particles will be observed in these points, will be observed in these points, you see, will be observed in these points and it will fall here. Right? Now, when the gun is kept here to measure this, so this will be indicated that it is attracted accumulation points, and we can able to understand. So finely milled iron particles coated with a dye pigment are applied to the test specimens, and therefore what happens? These particles are attracted to the leak field. This is the leak field. Here the field is going from north pole to south pole, it is moving. But here is the leak field, and these magnetic particles are also attracted to this field. So what happens? And will cluster to form an indication directly over the discontinuity. So when the iron particles are clustered, I am having the dye pigment colored iron particles. So we can able to find easily the accumulating point, because there is a leakage of flux. This leakage of flux absorbs the iron particles, magnetic. Iron particles will be absorbed. It will accumulate here. I am throwing this here. Iron particles are thrown here. But this flux gap will absorb more due to this attraction of north pole, south poles. Therefore what happens? These iron particles are more accumulated at this point. Now it is visible because it is colored, it is accumulated, and it is identifiable. Here it is where it is not accumulated, but the specific point is accumulated. I am identifying the color is more here. Therefore it is easy to identify the surface defects. Even some subsurface defect also. So likewise, the crack is available here. We say crack is available, and the direct of field I am applying over there, and it is magnetized current. Now pole to south pole it is magnetized. When this crack or accumulated iron particles are there, colored iron particles, I can able to find. Likewise it will be. So first what we have to do then? Now we understand there is a defect now. First defect, and then the field is created. After creating the field, what happens? We are spraying applying the magnetic particles over there. So we are spraying magnetic particles. Magnetic particles are attracted towards the crack, flux leakage gaps, and then we are identifying. We are seeing through the light sources, otherwise this colored iron particles will be visible. So we can able to see those things easily. So typical, what is the steps involved? What I told you. The clean area to be tested. Apply the contrast paint for identification of the contrast paint over there, over the cracked zone. Then only we are applying the powders. Apply the magnetization to the component, north pole, south pole is added there. After apply the ferromagnetic ink to the component. During the magnetization testing, interrupt the test area. Now it is tested. So here we are applying ferromagnetic ink in midst of the powder particles. Post cleaning, after demagnetization, post cleaning as usual. This painting and not the contrast painting and we have done. Therefore, post cleaning to be done. So that are the steps. See here how they are. Here we have made the correction of iron particles over there, and then this is the gun for magnetic and north pole creating gun. I am keeping there. And here this is in one hand the operator having the gun, in another hand he is having the iron powders box. Through that he is spraying. He is spraying there. Through when it is spraying, he can able to force over the gap between the ionized zone, so that it will be attracted there to the. If the crack is there, if the leakage is there, it will be attracted. So after attracting, you can see this. Likewise, it will be attracted there. So here the crack, visually the crack is visible. Such cracks can be visually inspected, and micro cracks which are not visible can be done by this magnetic particle testing. A crack like indication is visible there. We understand. So what we have to do? We have to first north pole, south pole magnetization, and then the iron particles throwing over there. These iron particles will be, due to this leakage of fluxes, it will be accumulated here. It will be accumulated at this point. So after accumulating, you can able to find, okay, this point is a cracked zone. So you can immediately find easy method. So see where how far this after this are visible. Some images. So likewise, so I want to show you this image. See here and all cracks are there. The contrast red colored iron particles are sprayed over there on the magnetized zone. These magnetized zones are attracted. These are the leak zones, flux leaked zones, magnetic field leaking zones. On the leaking zone, I am spraying the iron particles. These iron particles are attracted. This cracked zones, flux leakage attracts these iron particles, and it is fixed there. So iron particles in the red color. That red colors are falling over there. So after that I am viewing. It is identified. So one of the easiest method here. Then these points. So these points are all identified in the magnetic particle testings. So we can use about the fluorescence also. Instead of iron particles, red colors, we can use a fluorescence. Fluorescence also it will glow in the dark zones. That method also possible to do. So some of the cracks you see, we are identifying through fluorescence. Here we are identifying. So some of the identification we can able to do. So here this is the specimen which we visually looking, we are not able to find the crack. But after applying the magnetic particles, the same specimen looks like this, where the crack is visible. On this gear you see here, simply it is visual inspection, it is pass. Through visual inspection I am not finding defect. I am putting okay for this. But actually what happens here, you see here the crack is there. It is found through magnetic particle testing, MPT. Advantages is inexpensive and simple operations, sensitive to small discontinuities, immediate result. When we spray, it shows. As usual, this also does not have records. No records are there. Moderate skill is enough. here we are told for cracking to find in the ultrasonic skill is required, because identification of pulse echo itself very difficult. Knowledge, skill is required. But here moderate skill. Why it is moderate skill? The operator is going to move the hands, spray. If the spray is observed at one location, accumulated, finding. It is not to find what the echo is, whether the echo is the base echo or backward reflecting echo or the crack or the rough surface noises. No need, nothing. Here only simple moderate skill is enough. So surface as well as subsurface discontinuous can be detected. So disadvantages: surface must be accessible. In there, we have the large thicknesses, we kept the probe, it went, and subsurfaces, the large specimens we can able to find. But here, accessibility is needed because we want to do this spraying operations nearby. Therefore, accessibility is needed. Rough surface interfaces with the tests, part preparation is required. Ferromagnetic components only can be done because we are applying most important point. This magnetic particle testing possible only for magnetizable materials. Otherwise, other materials are not possible, because iron poles we are spraying there. The poles magnetic field we are creating. This flux leakage should function. Then it should be a ferromagnetic material. So that only it is possible in the magnetic. Other non-ferromagnetic materials are not possible. These are big disadvantages. So the same point I have given as a comparison points. You see, simple in use, inexpensive, rapid results, no report. Here we can write no report. No reports. Little surface preparations, possible to inspect through thin coatings also. So surface or slightly subsurface are possible, magnetic materials only. So here, important, magnetic materials only possible. Magnetic materials are only possible. No indications of defects on depths, only suitable for linear defects. So other, which is parallel, may not be possible. So linear defects to be there. Maybe point defect may not be possible. So next we are coming to the liquid penetrant inspections. So here we are talking about only surface defect, what we are doing. First we understand what I should do. I am planning to make a defect like this. You see, here the defect is there. Here the crack is there. I want to find. This is a surface crack. So when the crack is available at this point, this is the subsurface crack. It is not possible to find through this liquid penetrant inspection. What I am doing here, through this method, I am applying the spray particles, and then we can able to find liquid sprays. We will see that. You see, important steps involved. Clean the surface first. Apply the dyed penetrant. Remove the excess dyed penetrant. Apply the developer. Inspect. So here the two words we should remember. This is penetrant apply and the developer. Penetrant will be in the white color, developer will be in the red color. Likewise, somehow we can classify. See, first we are cleaning the specimen and then apply the penetrant where it is one of the spray type which gives a contrast other color. And then over there I am applying the developer, and also it gives the another contrast white color. So when developer is applied, this penetrant liquid will absorb the developer white. So we will get finally likewise some identification. We will see again. See, first step, cleaning. Clean the part thoroughly using a suitable cleaner of acetone or aqueous degrading agent. So first washing these surfaces which we are going to inspect. Apply the penetrant to the surface being inspected. So see, the penetrant which we are using is in the red color. It is a liquid and we have sprayed and the liquid is passed through the crack. Now it is ready. Now we want to wipe out all the remaining zones. It means just we are wiping out. See, remove the excess penetrant using the cleaner, solvent, and clean, dry and line it free to the cloth. Now it is dried. Here we have applied the penetrant and later just wiped out and cleaned. Wiped out done surfaces only, but the penetrant which is went into the crack are not possible to clean. Therefore, the penetrant is still present even though the surface cleaning has been done. This is our part. Now we want to find what I am doing. Apply the non-aqueous developer. What happens? I am applying the white color or contrast color developer over there. You see, as like penetrant applied, penetrant is already went inside. And over there, I am applying the developer there on the full surfaces. What happens? This red color liquid penetrant will be affected here and comes up. It means it is absorbing. This developer is absorbing the liquid penetrant. Therefore, what happens? This area will looks like red. This area will looks like red. Because it is absorbed. This white developer is absorbed this outside. So it happens. What happens? The evaluation should occur using the proper lightings. After doing this, it is visible. We have to some cases we should use the lighting sources in such a way we can able to see. You see, after applying the developer, it comes out. If after coming this, we are seeing this. You see, after coming this, it is visible contrast color. All the surfaces are in blue color. The contrast developer, it is in blue, but the specific zone, specific point where the crack is there, where the penetrant is not possible to clean, that comes out when the developer is applied there. It means developer absorbs the liquid penetrant. That point looks in the contrast color, so that we are visibly identified and we can able to tell that there is a crack and it is failed, not pause. It is a crack to be rectified. So advantages: highly portable, inexpensive. Only we have used 2 points, that is penetrant and the developer. Only 2. So inexpensive, just it's a visual inspection. But it is a liquid penetrant inspection. Liquid is penetrated inside. So liquid, the name says liquid is penetrated inside, and we are using the developer to extract out. Sensitive to very small discontinuities. Inspection can be completed in less than 30 minutes. We are applying, waiting for a while to absorb. Penetrant to go in, waiting for 5 minutes. And applying the developer, cleaning, drying, and then applying the developer, waiting for 2 to 3 minutes to observe. Visible, over. It may be complete in 15 to 20 minutes. So moderate skill is enough. Skill moderate is enough. So what are the disadvantages here? Only surface defects can be detected. Only surfaces defects can be detected. Subsurface surfaces are not possible because the liquid penetrant flow over the surfaces only. The subsurface which are having slag intrusion, structures, not possible. Liquid penetration test not possible. Radiography can use, ultrasonic we can use. Rough or porous surface interface with the test are not possible. The part preparation is required. Part preparation, what is the part preparation? We should clean earlier to applying of the penetrant. We should clean earlier to applying of the developer. So the steps involved is needed. High degree of cleanliness is required. High degree of cleanliness is required there. So likewise, you see, this penetrant is applied for conclusions. Penetration is applied. Then I have a cleaning process, and penetration does not comes out. It is available there itself. Then applying the developer, white color developer or any contrast color developer, and from the developer observes the penetrant and it indicates the defect. And just we are seeing, see here, spraying and cleaning the penetrant, and then applying the developer gives the contrast color. You see, these are not defects. There are no defects are there, it is not visible by normal visible eye. So applications we can use to detect the surface defects in the welding, casting, forging, material cracks, porosities, failures, everything. You see this image here, the cracks are there. You see various cracks which are not visible, identified. This is the white color is the developer. Already penetrant is applied first, and then when the developer is applied second, it comes out. So that is the idea. So that we are using a spray, first penetrant applied, and then the developers apply. It looks like this. It is a sequence of operations: penetrant, developer. We may use fluorescent penetrant also. We may use the fluorescent penetrant also. In case of normal liquid penetrant, liquid penetrant test, we can use the fluorescent penetrant also. Liquid having a glow. So in such a way we can able to see in the dark zones, dark area we should use for visibility. So likewise it will be visible. It requires ultraviolet black light to test. So that is one additionally needed for that. See some of the images how we are doing. So here and all some fluorescent penetration is used to identify. See fluorescent tests are used and he is doing the job. To how he can able to do. See if it's a close look up after applying the penetrant. Penetration is in the red color. And after applying the penetrant, I'm cleaning because everything should not be visible. The crack we have to identify. That is why I keep on cleaning. After cleaning, it looks like this. You see. After that, we have to apply the developer and we have to identify the spots where it is done. So it is a cleaning process. Here it is. After cleaning, it looks like red. Here it looks like white. You see. That is the identification we can able to create. So the summary of the session. In today's class we have seen about this non-destructive testing process. In non-destructive testing process we have divided into surface defects and subsurface defects. In the surface defects we have done about two of visual, liquid penetrant, and then magnetic particle testing. Right. In subsurface defect, I have done this radiography. And also I have done ultrasonic inspection methods. So this is about visual inspections, liquid penetrant test, and then magnetic particle test, and then the radiography, X-ray, RT, they will call it as RT here, then ultrasonic UT, RT, UT, MPT, LPT. So this is how we complete these sessions. The remaining part of the subject we'll see you in the next session. Thank you.